Today I want to talk about key points relating to hydrology and subsequently to water quality in regional landscape planning. Today I want to talk about hydrology as the building block to understanding water quality. Next week I'll talk more specifically about water quality. But today I want to try to talk about understanding water quality issues. And in order to do that, you have to understand hydrologic relationships in the landscape. Hydrologic relationships relate to atmospheric, surface, and subsurface water. The impacts of hydrology, soils, topography, and land cover have profound impacts on water quality. And that's basically what I want to talk about today, is the notion of hydrology, soils, topography, and land cover, and how they affect the movement of water in the landscape. So I want to start out with a basic discussion of atmospheric, surface, and subsurface hydrology. The next lecture will focus on water quality dimensions related to regional landscape planning. In this lecture, I'd like to introduce the concept of water scarcity. In that context, I want to talk about the hydrologic cycle, and within the hydrologic cycle, I want to focus on the atmospheric moisture regime, the moisture that's above ground, the superficial hydrologic regime, the moisture that's at the surface of the ground, and the subsurface hydrologic regime, that moisture which is below ground. We hear the phrase water, water everywhere, and indeed 71% of the global surface is covered by water. And not a drop to drink, the acute scarcity of potable, that is, drinkable water. We can characterize water on planet Earth. As I said, 97.2% is tied up in the oceans, and 2.8% is non-oceanic. Of the non-oceanic, 2.2% is tied up in ice and glaciers. These are glacial ice caps at the poles and alpine glaciers. And the remainder, less than 1%, is liquid vapor. Of the liquid vapor, most of that is underground. It is what we call groundwater, water that's underneath the surface of the earth. The remaining 0.02% is surface water. A very small amount of the surface water is atmospheric vapor. And so the non-potable water liquid that's available on the surface of the earth versus the potable surface liquid is about the same. In other words, we have about as much drinkable water on the surface of the earth as we have non-drinkable water, none of which is very large. So the total non-potable water is 99.4% of the water on the earth, and 0.64% is potable, either from surface or subsurface sources.